Today we will continue the influence line course. We will make an influence line for a Gerber beam, and we will not be drawing the influence lines from support reactions or hinge reactions because they are easier. We will focus on cross-sectional influence lines for cross-sections. We have such a beam, a vertical skate, 3 supports, 2 hinges. We need to draw the cross-sectional influence line for sections K, L, and M using the kinematic method, that is, without writing equations. So let's get to it. We break it down into simple beams to have an understanding of which beam is superior and which is subordinate. You already know how to do this. And as I mentioned earlier, here I draw a support on the superior beam. I do not draw it on the subordinate beam. It will be easier to determine what type of beam it is for drawing cross-sectional influence lines. I have prepared space to draw the moment at section K. Shear force moment, shear force moment, shear force moment for each section. Below the video you have attached tables from which I will be using. So we start with the influence lines of moments in section K. So I have this type of beam. Here I have a section on the beam. Here it is drawn as the third one, even though there is a continuation here. In my setup, there isn't. It could just as well be that the beam here would be longer. And this is the same situation, meaning I see that the influence line in section K will be a negative one from the skate to section K. And I have drawn it. Beyond that, I cannot draw anything more since, first of all, I am on the superior beam. And secondly, that is essentially the end of the influence line. Now, the influence line for the moment, I also see a positive value B. Value B is from the section to the support. Here it is 2, and here as well, so 2. On this board, it is upside down. Usually, we draw positive moments below, so I will draw it below here. Plus a positive 2 to the section, a constant value, and then it descends to 0. And I cannot proceed further to the subordinate beam following the rules of the kinematic method. Influence line in section L. Now, I have transferred this piece of beam we have here, and I wanted to tell you that if we have such a situation, we treat it like a cantilever. If we have a section, and there are 2 supports next to it, we treat it as if there was a section here. Well, rather a section, a regular such support. So now we have a beam from here to there, of the type drawn here, let's say the second. Only be cautious. When a cantilever or vertical skate is on the right side, unlike how I considered these basic situations, then the influence line for the shear force in section L has the opposite sign. So I must remember this. I have a cantilever on the other side. Here's the beam. It is 3 meters here. There's a section 1 meter from the cantilever. So the reverse value, which means we have -1 from the section to the free end, is 1. I can enter the main beam. So I enter, and remember, it will be like this every time when we move from the subordinate beam to the main beam, which ends with a vertical skate or complete rigid support. Then the value that stops here at the joint remains the same. And this is the only exception when the joint does not change the effect of monotonicity, because it is still a constant value. This we already have, now the influence line of the moment, so we look. The moment is unchanged, from the section to the free end, the negative value B. To the free end here B, and B is a value from the section to the free end as well, which is 2. And now the value does not change. Whether in shear force or in the moment, the value remains unchanged. Influence line of shear force at section M. Section M is already classic between 2 supports, we look here. It doesn't matter if there is this sliding, non-sliding, and here it is the reverse. It's the same, that is, we have at the bottom a over L, which is 3/5, which is 0.6 comma at the top. We have B over L, which is 2/5, 0.4 comma, and down to 0, 0. And now we are wondering, what from here? Well, I am on the subordinate beam. I can still move like this while I draw the influence lines, bounce off the joint, pass through this support, and here I remain with a constant value. Okay, and from proportions I calculate 0.6, 0.9. Influence line of moments in section M, well, this is the same classic A times B over L, 3 times 2, 6/5, 1.2, to 0, and I carry on in the same way, bounce off through the support and constant value, because here I have a beam that ends with a vertical skate, and still a value of 1.8 from proportions. There are even more difficult cases after all. Every case is different. So it's not possible to solve all cases in these videos, but I hope that now influence lines and section forces will be easier and clearer for you. Thank you for your attention. If something was unclear in this video, feel free to ask questions. Visit us on Facebook, like our profile, visit our website, and of course, don't forget to subscribe to us. Take care, bye.